All right, so here's one of the latest things, solving systems by graphing. And to be honest, solve by graphing is probably the least popular, but I'm going to show you kind of how to do it anyway. It's very specific as far as if it's set up this specific way, you can do it. If not, honestly, it's just easier to do it one of the other two ways. I can tell you when we get to 3 variables, this won't work really at all. So just bear with me on that. So first thing we did, and again, you can pause and copy down and then unpause, rewind, however you need, because I'm going to talk fast. And basically, is the ordered pair a solution to the equation? Is this point a part of this line? Well, if you take the x and y and plug it in and then see if it's a true statement, if it's a true statement, then yeah, this point is on this line. If it's not a true statement, no, this point is not on this line. It's maybe nearby, but it has to be a point on the line for it to be a solution. So we did a couple examples. Then we talked about systems. Is this point a solution to the systems here and here? Systems is basically this. I have 2 lines on my grid and they cross somewhere. My solution is where they cross. So that's our whole goal with systems. We're trying to find out, we got 2 lines, where do they cross? What's the solution for these system of linear equations? Well, if it's a solution, this point is true for this line, and this point is true for this line. So if we take x and y and plug it into the top, get a true. Take x and y, plug it into the bottom, and get a true statement. If both of them are true, and this point is on both of those lines, then yes, that is a solution to these. Now, these lines do not represent what's going on here. I really just drew something real quick. So don't think like, oh yeah, I absolutely have to graph. And I told my kids, I'm not worried about you drawing it. This is not an art class. It's about you finding what needs to be found. So what happens if it's not? We have this x, y, and we plug it in the first one, and yep, true statement, cool. Wait, this is not a true statement on the bottom one. Sorry about that pause. What happens when we don't have 2 true statements? Well, it's a part of the first line, not part of the second line. So all we can say is no, this is not where these 2 lines cross. Well, where do they cross? It's kind of our next question. If it doesn't cross here, where? And I got this covered up because we're going to come back to this. But here's kind of how we do it. Solve the systems by graphing. And we got these 2. And I'm going to pull up my calculator. Press pause. Here a second. And you just hit this y equals button. And we got this. And we're just going to type these in. Here's your negative button here. Don't use the subtract sign. Otherwise, you'll get an error. And here's your x button here. So give me a second. I'm going to type these. And now that I got them plugged in, you can hit the graph button. Problem is, the graph's not perfect, and we can tell it crosses here-ish, but is that exact? And, I mean, we don't really know. Luckily, we can find out. The graph button above it says table, so if you hit second and then graph, you come to the table. And I told my kids to show their work. I basically want this right here, from -3 to +3. And once we put our table down, we're looking for where y is the same. If I plug in x, it spits out y the exact same both times. So here on my table, you see it, 1, 3, 3. Well, 1, 3 is a point for the y1 graph, and 1, 3 is a point for the y2 graph. This is where they cross, at 1, 3. At x is 1 and y is 3 is where these 2 cross. And the table in your calculator can help you get that fairly quickly. The graph, you can kind of see maybe it should be 1, 3, but the table will help you get it exactly. Now, let's go back here. The table for this one, if I move that out of the way, looks like this. And we could, here's our y equals, and our graph looks like this. So it crosses here, and maybe it's -4-ish. Okay, well, maybe we should go to the table and see like -4, well, no, -3. I mean, okay, so what about here? where that says -4, +4. Well, those are different numbers. If you owe $4 and have $4, those are two different things. So we go, what's happening here? I don't understand. And I'm going to clear this so you can see. Here's how we do it in the calculator. We can find this point exactly. Hit the second button, and here's your history down here. And then this trace button, because above it, it says calc. We want to calculate. Now, if you remember, they cross somewhere. Which of these looks like it might be something where it crossed? And it's this intersect, like an intersection between two streets. So you can just hit the number 5 or arrow down, and then it's going to ask some weird questions. What's the first curve? And honestly, just hit enter. Well, now it's asking for the second curve. Just hit enter again. And now I want you to make a guess. And I mean, you can just hit enter a third time, and boom, here's the intersection. Well, that's why we couldn't find it on a table, because it's decimals. So again, if you want to if you want to take a picture of this right here, that's our how to get what's going on. Second, trace, 5, enter, 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 and we get decimals. And decimals could be fractions or fractions. Like these are all the same, and you just got to be careful. So the problem is, and we did another example, found it in the table, fairly easy. So you can go to y equals, type them both in, bam, we found it in the table. The problem is, let me get to it. Do you see how both of these said y1 and y2, or basically y and y, and I put 1 and 2 next to it? It's because they're both saying y equals. We can go here and make them both say y equals. Pretty easy, right? Does this one say y equals? Well, no. So we can't really type that in there. We can, but honestly, it'll be so much easier to do it one of the other ways I show you. It can be put in the calculator. This can be put in the calculator. You just have to make it say y equals something. And you make it some fractions, which for slope and stuff, it's not a terrible thing. But it's just going to take a little bit different work. We have so much easier methods to solve these rather than trying to do it that way. And I had one more example. This didn't have anything to do with graphing, but it was some system of equation stuff. It was my throwback to how to solve an equation. How to think, okay, my equation is a balanced scale. 6a equals 72, that's a balanced scale. Well, if I do anything to one side, like if I want to add 10, if I wanted to add 10 over here, then I need to make sure I add 10 over here to where it's even. If I want to divide by 15, then I have to divide by 15 to make sure it's even. Whatever you do to one side, you do to the other. Now, our goal is to get variable equals something. So to get rid of anything, you do the opposite of what you see. I see 6 times a. I see times 6. To get rid of times 6, we're going to divide by 6. And as long as you do it to both sides, we can really do whatever we want to this equation. Once that happens, we get our answer for our adult ticket. Our adult ticket is $12. Well, if this a equals 12, what does this a equal? It is still 12. You can see down here. So now that we have this, we're going to just plug it in, kind of like we did with our x's and y's. And all we have to do is solve for c. Here's a couple step equations. That becomes 96. I have 4c plus 96. Well, that's all connected, and this is kind of off by itself. Well, let's get rid of the plus 96 by subtracting. Now I have 4c equals 32, and I went really fast. I'm really sorry. But we're going to, I don't want to do that. Well, we're going to divide by 4 on both of these to get a child's price is $8. And I should have had my $ units there and there. So systems is really all about using some different information to figure out the piece that's missing. That's all systems is. It's not too bad. I'm going to show you some other ways to do them here in the next couple days.